Hi everyone, welcome back to this channel. So this is the second part of the ENA-X setup walkthrough, and in this video I'm going to focus more on the gain compression analysis. So as you might know, that gain compressions is one of the parameters that we test to determine the stop of the linear zone of an amplifier. So the definition for gain compressions measurements is that when there's a change of 1 dB in the input to the amplifier, there is less than a 1 dB change on the output of the amplifier. So in linear zone, it works out like the formula y equals mx plus c. So anything changed on the x will change the value on the y. So for example, if I change 1 dB on the x, so in linear zone, the y will change by 1 dB. So that's the theory, and with this software we are able to determine across a frequency range instead of doing point by point measurements. So without this software you can still do it, but you have to stop at every frequency point, stop at the same frequency, for example 1.5 gig stop, and then you vary the input power. Then you determine when is the region where the output power doesn't tally with the input power in terms of changes. This is a pre-setup I've done, but I'm going to walk through the beginning step by step again. So let's preset this. So before we jump into the gain compression analysis, so let's determine at one frequency what is the power level where the gain compression happens. So let's do the traditional way. Let's change the measurements to S21. So currently it's not turned on, and we're going to set the frequency between 1 gig to 4 gig. Start at 1 gig. So as you can see here on the right side on the camera, it's the same HP 87405B that we are using in the previous video. So the gain is about 24 dB according to the spec, but when we tested in the previous video it was about 22, 23 at 1.5 gig. Okay, the next thing I want to do is let's turn on the marker. The middle range is 2.5. Let's work with 2.5. So the gain is off right now. Let's change the power. Currently 0 dBm is a bit too high. Let's change it to minus 15 dB. So I'm going to turn on the unit right now. So at minus 15 we have a gain of 22.72. So let's change that value. So okay, let's say we set it to 13 so that you can see that difference right now. At 13, the gain is about 22.43. If you can't really see what I mean, let's turn on another trace. Let's do a measure and let's put a receiver B, so that you can see that change in the receiver by changing the power. So at 13 dB, it's 9.22. So if I change to 12, it should be, so you can see that it's less than 1 dB change. Let's start with 15 dB, and then you can see that. So if I change to minus 14, I should get about 8.5 because I increase a dB, roughly that. And then if you change to 13, so it's 9.22 from 8.4, so it's literally less than the dB. So chances are the range is between 14 to 13. So just bear in mind this is not calibrated, so this is roughly around that range, and one of the constants will be the cables here. So if you want to go down that path, let's do that. I'll turn off the amplifier and then we run a quick cal. So let's do that. Smart cal, perform guided. We want to make sure power. Alright, that's next. So female, and power meter setting. Like previous video, just go to power meter setting, make sure that the USB sensor is detected, and then select, and then just click OK. And port 1, so this is what we want to do, ecal, auto orientations, that's it. So power sensor to port 1, then we click measure. Maybe we should change it to minus 15 and remeasure. Right, then port 1 ecal. Measure. Port 2 ecal. Alright, put an adapter between port 1 and port 2. So the time difference is about that 2.39, 2.4 centimeters. Okay, so now we're quite happy with that. The loss is about 0.0 dB. So let's change the power. So let's start from 15, which is about here. So 8.1, and then 14 we should get about 9.1. And then from 14 to 13 we should get about 10. So it's less than the dB right now, so you can consider that it range from -13 to about -12-ish. So that's a region. Just keep that in mind. So we're going to do that in our gain compressions analysis. So I'm going to create another channel, channel 2. Let's do the display so they can see two different things at one go. So let's move this up a bit. So in this second channel, so I'm going to set up this measurement to gain compressions. Yes. Start 1 gig, start 4 gig. So I don't really want to change the rest of the number points and whatnot. And smart sweep. Let's go with that for now. You can also specify on what you want to do. But the smart sweep is both frequency and amplitude at the same time. Sweep power per frequency means that they set one frequency and then they sweep the power. The other one is sweep frequency per power. And power, so this is one that I have to change from -15 to maybe -8. I don't want to saturate my amplifier. Reverse power, just leave it as it is. And I just did a quick check. The difference between internal and receiver. Internal, it's from the reference point measurements, so that's how they level down the power. Receiver is on the other end of the receiver, so they want to see what's the difference. If you want more accurate, go with the receiver. If you want general testing, internal will be fine. So compressions, level 1 dB, tolerance 0.05. Right, so apply, okay. Let's turn on the marker. So as you can see right now, this is not calibrated. So there's a bit difference, 22.85, 22.9. So this is S21. So we have to create another couple more traces so that we can see different things. So the first thing I want to see is the input, because I want to see where the saturation point is starting in x-axis, and I want to see the output. So it's just a measurement of the receiver, just like this B1 value. Then the last one, I want to see the delta gain. Just want to make sure that at a point is less than 1 dB. So we have this done actually. So it is actually sweeping the input power, and this is what you're going to see. So the output is about 10, and the delta is the gain, it's about 21, 22. So this is what happens when they determine the gain compression region. So this is the delta that we're looking at. So it's actually as simple as that. So once you set it up, so you're happy with that, so let's go to Smart Cal and make sure that it's under GCA, gain compression analysis. So we run the cal again. So power meter, we already done it. So next, same thing, power down, remove the amplifier and do the calibration. Power sensor, port 1, measure. Oops, I should change the power level to -10 because it's between -15 to -8-ish. So we should move it closer to the range that we want to test. Let's go back, -10. Next, oops, next. Port 1, ecal. So one of the reasons why I have to keep changing the ecal to port 1 and port 2 instead of having both ports connected to the ecal is that I have the opposite gender on each part. I so wish that I have both female for this case, so that I can just connect the ecal in between two ports. Port 1, port 2, adapter. Yeah, so it's about 2.39 centimeters, 0.07970. Okay, so the next thing we want to do is to add in the attenuator in middle. So according to the GCA, the cutoff point is at -12, and the gain at the time it's 23.56, and this is the gain compressions level that we set. So it's as simple as that. So you can do the comparison between these two channels. The channels is like grouping two different tests into one view, and it's alternating between these two channels, the testing, the update. So that's it for gain compressions analysis, and this is how we do it. So in summary, you don't really need channel 1. So you go straight to channel 2, turn on GCA, and then from GCA you do the setup, quick setup. So some expert will do it from right to left. So make sure the compression is set correctly, power is a range that you have to set, and then we go to frequency. So this is a range, number of points, whether we want to do a 3D sweep or we want to do a 2D sweep. Then once you click that, run the calibrations as I've shown you, and this is the end result. So I hope this helped. Thanks for watching.